Today we're going to be graphing linear inequalities. Linear inequalities are solved and graphed the same way you would a regular linear equation or function, with a few exceptions. So let's get started. Number one, the first thing you will need to do is you're going to solve for y. So if it's not in that slope-intercept form, we're going to have to solve for y. So take a look at the example. The first thing you would do here, treat it just as you would an equation, and you're going to subtract x from both sides. 2x from both sides. Bring down your negative 3y. Bring down your less than sign. Write in your negative 2x plus your 12. Then you will take and you will divide all of your terms by negative 3. Now, the inequality rule is that don't forget to change your sign when you are multiplying or dividing by a negative sign. So I'm going to just write a note down here. Don't. Don't forget to change the sign if you divide, and multiply as well, but in this case we're dividing by a negative. So our final answer here will be y is less than, I have a negative 2x and divided by negative 3, so that becomes a positive 2/3 x minus 4, because I have a positive 12 divided by a negative 3. So here is my final answer, and this is what I want to graph. So in my second step, now that I found my slope-intercept form, I'm going to graph, still using the slope, and the y-intercept. So in my equation, my slope is still the 2/3. And my y-intercept is the negative 4. So in number 3, I need to decide whether I'm going to have a solid line or a dashed line. So now I'm going to come down here and we're going to graph our inequality. The first thing we would do, the same as we do on an equation, we're going to find our starting point. So the starting point is here, because this is actually our y-intercept. So this is your B, your y-intercept, which is going to be 0.0, -4. Then come here and go down 1, 2, 3, 4. And then I'm going to start to move. My rise is 2, 1, 2. My run is 3, 1, 2, 3. And I will start to create my line. I'll start back at my beginning point and do the opposite. Down 2 and over to the left. 1, 2, 3. Down 2, over to the left. 1, 2, 3. Now I have to determine whether I have a solid line or dashed line. So let's review over here on the side what's going to make it a dotted or solid line or dashed line. So here are your inequalities that you would be looking for. You have your greater than, which points to the right or equal to. You have your less than, which points to the left or equal to. And then of course we always graph our equations, the equal to sign with a solid line. So all of those inequalities or equations will be using a solid line. The dashed line is just the greater than, which points to the right, and the less than, which points to the left. In this case, we're using a dashed line because of our inequality is less than. Doesn't have a line under it, so it doesn't include the points that are on this line. So I'm going to make my line a dashed line. And I'm still have that linear formation because it does have a constant rate of change of 2/3 or a slope of 2/3. Now we're going to decide how to shade. That's the difference as well in a linear inequality. So now we're going to shade. So to determine whether we're going to shade up or we're going to shade down, we're going to shade on in this part of the region or shade in that part of the region. Let's go here to shade above. To shade above, it needs to be greater than. That would include the greater than sign and also the greater than or equal sign. The less than will be shaded below. And those will be the less than sign or when you have the less than or equal to sign. Don't forget that when we solve for an inequality, if the sign changes, if there is a negative in the coefficient and we're multiplying or dividing, it's going to change the sign. So now when we go back and look at our equation, we know we have we have to go back and change our sign. Because we started with the less than, we divided by -3, so now we're going to change this to greater than. Therefore, we're going to shade above. That means that every point in this shaded region or area is a part of our solutions. Any point that is in this shaded region is a part of our solution. Any point that's on the line is not part of our solution because we have a dashed or dotted line. Any point that's not shaded is not part of our solution. So when we look at point negative 4, that is not part of our solution. 0,4 is part of our solution. Take a look here. 1, 2, 3, negative 3, 1, 2, 3, 4, 5, 6, negative 6. So point negative 3, negative 6 is not part of our solution because it is actually on that dashed or dotted line. Okay, now you're going to take and paste this into your interactive journal.